Hi all. In previous sessions, we have seen some features of Java programming languages. So first five we have seen previously. We have covered in the first part simple, platform independent, multi-threaded, high performance, and highly interpreted. In this session, we are going to discuss remaining features. So we'll try to understand what is a robust or what is a strong. Why Java language programmers they are saying Java is a robust programming language or strong programming language. We'll try to understand that now. So why they are calling Java programming language a robust or strong is because let me write here it's a robust we can call it as a strong. So because it contains facility called exception handling. We'll try to understand what is this exception handling. So, what is the exception first of all? Exception is nothing but runtime error of your Java program is known as an exception, right? Suppose you write some program, let's say some addition program you are writing. So, into a equal to 10, into b equal to 20, and c equal to a plus b. Some logic or functionality you have written your Java program. So while running this Java program, if any error occurs, that means runtime of your Java program, if you get any error, that error we are calling as a runtime error, calling as a exception. That is an exception, right? So first we'll understand what type of errors in general we can consider. So in general we have different types of errors, right? Let us take, we can have compile time errors, and we have logical errors, and we have runtime errors. So when you will get the compile time error, you are writing one program. If you don't follow the syntax of the programming language, suppose you are using one Java programming language. So Java has provided you some syntaxes, right? If you don't follow that syntaxes, if you compile this your program, automatically you will get the compile time errors. These are the one type of errors we get it. And what about the logical errors? Logical errors are occur in general it is due to a misinterpretation of logic. Suppose I want to I want to add two numbers. This is my program. But logic, instead of adding, I will write a minus b in the logic level. So obviously what I will get it? Suppose a equal to 10, b equal to 20. So I'm expecting a plus b logic. That means how addition it will add this 10 plus 20 and c equal to 30, right? This is my expectation of the program. But while develop the program, writing the program, if you write other logic, suppose a minus b you have given, so that what happens? A minus b minus 10, right? Like that I'll get it. So due to the misinterpretation of logic, if you get any errors, that is nothing but a logical errors. What is a runtime errors? Runtime errors are nothing but it occurs in the execution time. Suppose you are writing one program, you are executing your program. So during your execution of your program, you will get some errors due to suppose user enters the invalid input. Let's take one example try to understand this. Suppose I have written one application saying that input. So let's take username and password. This is my application. So username should contain one alphabetic and numeric number and special character. This is a mandatory for your application. Suppose when user enters only 123. Okay, what happened? They will get by default if any this kind of errors. By default, system can generate error messages. That we call it as a system generated error messages, or we can say technical error messages. So in general, if you get any of your error, like I mean during the execution of the program, if you come across any error, by default system can generate error messages, or we can call it a technical error messages. How it will display technical error messages? Instead of showing all the things, it will show, can I close the application? Suppose let's consider this is a one technical error. For all the technical, I mean for all the inputs, it will show this one only. Suppose user can enter string. Suppose I'm M A K. So all string I'm giving. Obviously error will throw, right? Because your application developed, these are the mandatory. They're only that input will accept. But here user enters only string. So same error, same technical error message it will show. Suppose user can enter only special characters, that time also same error messages it will convert, right? But this is not the best practice. You have to convert the all the system generated error messages, nothing but technical error messages, you have to convert into user defined error messages. So how I can convert? So I will handle this situation whenever user enters only numbers or strings. By that time, I should populate one error messages. Username should must be one letter, one special character, one string. Then only it will accept. So that okay, easily user can understand this error message. He will enter the proper username by that time, so that application will accept that username and password and execution will be happen. So the conversion of system generated error messages or technical error messages to user defined error messages is nothing but a exception handling. So now I hope you can understand the exception handling. Exception is a nothing but a error of execution of the program, right? During your execution of the program, any runtime error if you get, that is an exception. The converting the system generated error messages or technical error messages to the user defined error messages is nothing but a exception handling. So Java has a facility called exception handling. So that is the reason we are saying Java is a robust or strong programming language. If you take any other languages like C, C++, COBOL, Pascal, right? These programming language doesn't contain this facility, exception handling facility. That is the reason those programming languages we are calling as a weak. But when coming to Java or .NET, we can say these are the robust or strong because they have facility called exception handling. Because of this, due to this exception handling facility, Java programming languages populated as Java is one of the robust or strong programming language. So this is a one feature. And let's go to another feature. So next, dynamic. What is a dynamic? We'll see what is a dynamic now. Let me go to one more board. Okay. Let's try to understand dynamic, why they are saying programming language as a dynamic. So in any programming language, we have two types of memory allocations, right? One is static memory allocation. One is dynamic memory allocation. So this is a static memory allocation. This is a dynamic memory allocation. All right. So in static memory allocation, what happens? Memory space is created the input of the program at the compile time. That means, okay, let me take C. See what happens in the C. If I write one program, suppose I have written one program. So I am just declaring one array, int array. So what happens? When you compile the C program, so memory will be allocated at the compile time only. So it will create one memory for you. 0, so 100. So this is in the C and other programming languages. At the compile time only, the memory will be allocated. That is nothing but a static memory allocation. But if you allocate the memory in the at the compile time, that means static memory allocation, we have some disadvantages. What are those disadvantages? See, I have created 100, right? 100. So memory allocations has created, but in program I am using only 5. So 0, I want to store just only few values, 3, 4, or 5. So 5 memory spaces are occupied, but whatever the remaining one, it's a waste of memory, right? So this is a wastage of memory. This is a one disadvantage only, right? This is a one limitation. And what is another one? Loss of data. Suppose I have created 5. So during the compile time, 5 memory allocations it will create for 5. But I want to store 20. What happened? Where it will create? So I can't store these values, right? So this is a one limitation, loss of data. And this is a wastage of memory. So these are the some limitations in the while providing, that means while giving the static memory allocation. But when coming to the Java, so it will create the memory only at the runtime, not in the compile time. So this is a dynamic. It will Java provides dynamic memory allocation. When it will provide the memory only at the runtime, not in the compile time. That is the reason Java programming follows only dynamic memory allocation nature only. So since Java is following the dynamic memory allocation, that is the reason some developers has populated that Java is one of the dynamic programming language. So conclusion is Java is following the dynamic memory allocation only, not the static. That is the reason this is a dynamic. So next we'll try to understand the another feature. So what is the next? Secured. Let's discuss about the secured. What is a secured feature in the Java? So let me take another board here. Security is one of the most principal, right? If you're using any project, security is very, very important because you confidential information we have in the projects level, and we have to secure that pro information from the unauthorized users, right? So in C or any other languages, if you take C, C++, all the things, what happens is they don't have any inbuilt facility, like there are no existing libraries for security to provide the security. They have to write their own security programs to protect that information, their project information. So it's a bit complex, and there are no inbuilt facility. Okay, but when coming to the Java, we have programming. Actually, we have separate programs, dedicated libraries, we can say. We have dedicated libraries, APIs. Okay, dedicated libraries. That is nothing but we have a set of APIs which dealing directly to the security. That means it will provide you the security to your data, or we can say project, so that Java programmers need not to write any separate security programs to protect your data. So if it's readily available security programs, these are presenting in the existing of APIs. So it is a few APIs, I mean existing APIs, Java X security.x. So readily it's available. By using this, you can protect the data from the unauthorized users in your project. Since it contains the readily available security APIs, Sun Microsystem has populated Java is one of the secured programming languages. This is about the secure. Let's try to understand the next feature. Architectural neutral. Okay, let's try to understand what is the architectural neutral. So I'm just writing just AN. AN is nothing but architectural neutral. So we have discussed earlier session platform independent, right? What is a platform independent? It is with respect to OS. If you write one program, that program can execute any of the OS irrespective of vendor. Suppose Windows, Linux, Solaris, any OS it will execute. Then that programming language is called as a platform independent, right? And when coming to the architectural neutral, it is with respect to processor. So whatever you are writing the program, that program can run in the any processor. Suppose i3, i5, Celeron. If you take any processor, it should your program should be executed. Then that calling we can call as a architectural neutral. Let's say, let's me take one small example. Suppose I have mission one. Okay, in the mission one, I have OS. Let's consider that mission contain OS as DOS OS I'm using. Okay, OS operating system is a DOS. And what is the processor I'm using? Processor is i5. And the softwares which I have installed is Turbo C3. Okay, so let me consider one factorial program I'm writing in the C. Okay, so Turbo C3 and I have installed my JDK, that is nothing but Java. So fact C is a program, right? When I compile, what happens? When I compile, it gives me the fact.object file, right? So during the execution of the program, if I execute this program, fact dot what it contains, it's a binary code, and program of this one, and 16 digit number it contains. What is this 16 digit number? The 16 digit number is nothing but a key of your processor. Suppose you are using i5, right? So this 16 digit number is nothing but a key of processor, key of your processor. Or we can say this is a factor. Okay, this is a factor. So other mission, suppose let's take this is a one mission. I'm using same Windows as a Windows I'm using Windows DOS and processor. Let's consider processor I'm using Celeron. So this is another processor, and the softwares I have installed Turbo C3 and JDK, some other versions. Okay. So what happens is if I same like when I execute this program, this also contain fact1.exe same program. If I consider, so this is also binary code contains, and this is optimized instructions and 16 digit number. This 16 digit number is related to your processor ID, key of your processor or factor, we can call it as it. If you run this same program, whatever you have written in this mission one, whatever you have executed, if I try to execute this one, what happens is it will give you one error. What error it will give you? Do you want to rebuild? Yes or no? That means you're rebuilding again that program. If you say yes, then it will rebuild and execute it. If you say no, it won't execute this program. So this is a architecture. This is not an architectural neutral, right? Because automatically it is not converting one processor type key factor into another processor key factor. Okay, automatically we are not converting here. So that is the reason this is not the architectural neutral. When we can say architectural neutral is the program can automatically convert this one processor key factor I mean with this processor, right? Automatically it will convert and it will execute your program. So that facility Java has. So Java has that facility actually. It contains some special program. What is the purpose of that role? What's the program role is? It converting the factor or key of the processor to the another processor factor. Okay, that is the reason we are calling as a Java treated as a architectural neutral. I hope you understand. So conclusion is architectural use neutral is nothing but whenever you write a program, your program should run in all the processes irrespective of vendor. Any processor, it should execute and it should give you the results. That is a architectural neutral. So Let's try to understand the next feature, portable. Okay, what is portable? We'll try to understand now. Portable is nothing but, okay, let me write down here, portable. What is portable? Portable is nothing but portability. Portability means easy to carry, right? Let's take small example. I have TV in my home. So I can easily carry this TV, right, to my master bedroom or hall or kitchen or anywhere, right? Portability means what? Easy to carry. Okay. So when considered to the programming language, portable is nothing but it should be platform independent plus architectural neutral. Then that programming is known as a portable. So if any program language, it should satisfy the programming independent, platform independent, and also architectural neutral. Then the programming language we call it as a portability. We can say okay. Every non-Java language and you can say I mean to say other languages C++ all the things, right, those are non-portable because it not satisfied that portable, I mean platform independent and architectural neutral, but in Java it has satisfied these two. It should be platform independent and it is architectural neutral. Because of this Java programming we are saying as a portable, so portable facility or future we can say. So and also few slogans we have in the Java, Ora, that means write once, run or reuse anywhere. And also frequently we can hear Oda. This is a core Java actually, like you can write a program once and run that program or reuse that program anywhere. And also WODA. This is a server side actually. Server side, what we can say, write once and deploy anywhere. Let me write here, write once, deploy anywhere. So these are the slogans we can have. So industry is performing to use portable languages for development of the most of the distributed applications. So if you want to develop any distributed applications, industries prefer or industry can give the suggestions to use the portable language. So Java is a portable language. Why? Because it contains platform independent architecture. So next, we'll try to understand the next feature next. Network. What is a network? Okay. Why programming language, Java programming language developers are saying it is it contains the network feature. What is a network? So network concept, it's relating to the connectivity. Connectivity of two or more graphical devices, computing devices. Computing devices means it should anything like any network related things, any computing devices, if it is a facility to connect the two or more computing devices together so that we can share the resources. So Java has one facility called Java socket programming. So Java has socket programming facility. It provides a facility to share the data between two different computing devices. This is a one computing device. This is a one computing device. Okay, we can share the resources from these computing devices to these computing devices. Computing device can be anything. It can be machine, it can be mobile, or it can be anything. Any computing device. So any computing device, it has a facility to connect between the two computing devices. So that what is the advantage of this? We can share the resources. If you want to share one resource from one computing resource to another computing resource, you can share this, and also we can centralize the software management. Okay, these are the two advantages of the networking program. So Java has an inbuilt facility called Java socket programming. It provides, that is a reason it is a network. Java is a contains a network feature. And we'll try to understand the next feature, distributed. what is a distributed? We know that. Okay, let me take one example here only. Okay. So it facilitates, it gives you facilitates users to create the distributed applications, right? We have discussed already what is a standalone application and what is a distributed application. Distributed application is nothing but a internet softwares, right? If you can take any Gmail or Facebook, all these are the internet applications, right? We can access these distributed applications from anywhere. It is not restricted to any mission, or it is not restricted to the any geographical location. From anywhere we can access these distributed applications. If you want to develop any of the distributed applications by using Java, you can create it. It gives all the facilitates users to create these kind of distributed applications. So this is about the distributed. So then that is the reason they're calling as a, it provides a features for distributed applications creation. And last one is object oriented programming. This is a separate section we'll deal with, so that we'll continue with our Java programming language. I mean, we'll start the programming from here. So till now we have discussed all the theoretical part. So let's discuss this topic in the next session. Thank you all.